This is a quick video demonstrating how to set thresholds using the measurement tool. We'll pick an area that has fairly good nuclear segregation, create a parent annotation, start with positive cell detection. It has default settings for thresholds, so we'll want to use summed optical density. Requested pixel size is good. Sigma we will set at 2. That's a Gaussian smear. We don't need to see the cytoplasm. And we will choose multiple thresholds. When we run this, we see the default values for the thresholds are used for the classification of the nuclei. You can slide the opacity to see the nuclei. Each of these nuclei is now an object that has 33 specific measurements. So we'll show the measurement maps, choose DAB mean, now we want to set the thresholds for 3+, 2+, and 1+, remembering that these are actually a range. So if we take a look and say, all right, I identify this as a high range 3, this nucleus right there. I drop this back until that pops out. Then I want to check, well, this one is also a high range 3, so I'll drop that back. Are there any other 3+ that are still classified? This looks like a lower range 3+, so I'll drop it back there. So that looks good for my 3+ range. I'll enter that into the 3+ range, 0.93. Now let's take a look at the 2+ range. I'll find a 2+ nucleus. That's not a bad 2+ nucleus, so we'll drop this back until that pops out. Keep looking for 2+. That's a little bit of a 2+ right there. So we'll take that one out. This is a low range 2+. So we want to take that one back as well. So that gives us a 0.49 low end 2+. So I'll say 0.49. Now let's take a look at the 1+ range of the nuclei that are still classified in the measurement map. Let's take a look at, this is a good 1+. So I'm going to drop it back until that 1+ pops out. Keep going. This is a 1+. Any other 1+s that we can see that are still classified? This is a weak 1+. That's at 0.22, 0.22. I run the classifier, close this, and this is my threshold set with reliability and reproducibility. I can come back at any time and get within probably 100th of the same threshold values. Now, when we run the annotation script on this, we can see that for the entire image, the DAB mean is this. Our selection for the nuclei is this. The proportion of negative 1+, 2+, and 3+ is this, and this corroborates a score of positive if the cutoff is 60%. So that demonstrates very quickly how to set the thresholds in a way that's reliable and reproducible. Thanks.